Welcome to all of you in this video lecture of the subject Advanced Software Engineering Principles and Practices. So in last video lecture I discussed about business area analysis. What are the goals of business analytics? What are the importance of business analytics in software development companies or ITs or in any development firm organization. So now I'm going to explain the next topic which comes into the module 1 of the subject. So the topic name is emergent properties. So emergent properties are properties of a system as a whole rather than properties that can be derived from the properties of component of a system. Emergent properties are a consequence of the relationship between system component. They can therefore only be assessed and measured once the component have been integrated into a system. See, this is the technical definitions. If I talk about in general terms, what are the emergent properties of a particular software while it is underway in the development phase. So the answer will come as emergent properties are the system's component properties. Means these properties relate with the subcomponents properties of a particular system as a whole. That's why its consequences of properties relates between each and individual component of a product. These are some examples of emergent properties. Emergent properties, the examples like volume is one of the most important property of software systems. Reliability, security, repairability, usability. See, these are the main properties. There are different emergent properties are there in the concept of software engineering, but the main things, the main pillars which will have to take in a way as important property like volume, reliability, security, repairability, usability. So let's explain all these properties in detail. So volume means the volume of a system varies depending on how the component assemblies are arranged and connected. Reliability means system reliability depends on component reliability, but unexpected interactions can cause new types of failures and therefore affect the reliability of the system. Security. The security of the system is a complex property that can't be easily measured. Attacks may be divide that were not anticipated by the system designers, and so many defeat built-in safeguards. Now, repairability. The property reflects how easy it is to fix a problem with the system once it has been discovered. It depends on being able to diagnose the problem, access the components that are faulty, that have some errors, and modify or replace these components as early as possible. Next one is usability. The property reflects how easy it is to use the system. It depends on the technical system components, its operators, and its operating environments. The emergent properties can be categorized further into functional properties and non-functional properties. Functional properties appear when all the parts of a system work together to achieve some objective. Means each and individual subparts of a particular system or product work to achieve a single goal. For example, a bicycle has the functional property of being a transportation device once it has been assembled from its components. Next one is non-functional properties. These are the reliability, performance, safety, security. These relate to the behavior of the system in its operational environment. They are often critical for computer-based systems, as failure to achieve some minimal defined level in these properties may make the system unusable. So these are the emergent properties of a system. So we should understand what are the system actual is in ADSE. So let's go into the background of the emergent properties of software. Like for many computer based systems, the most important system property is the dependability of the system. Means how a system is dependent to other on another. The dependability of the system reflects the user's degree of trust in that system. It reflects the extent of the user's confidence that it will operate as users expect and that it will not fall in normal use. Dependability covers the related systems attributes of reliability, availability, and security. See, dependability means a particular system should be reliable, a particular system should be available in any circumstances, a particular system should provide the security. Security is a big factor. Security is a big factor. It's easy to develop a particular thing, it's easy to design a particular thing, it's easy to fulfill the requirements of customer through a software functionalities, but it's not easy to fully secure, to provide full secure system to user or customer. That's why security is most important factor while developing or while you are considering to design a particular product. These all are interdependent. System failures may have widespread effects with a large number of people affected by the failure. Systems that are not dependable and are unreliable, unsafe or unsecure may be rejected by their users. Surely, the cost of system failure may be very high if the failure leads to economic losses or physical damage. Undependable systems may cause information loss with a high consequent recovery cost. So what we are talking about again failure. So what are the reasons, what are the causes of failure? Here is a hardware failure, software failure, operational failure. Hardware fails because of design and manufacturing errors or because components have reached the end of their natural life. Software fails due to error in its specification, design or implementation. Operational failure, human operators make mistakes like developer, designer, coder, tester, implementer. Now, perhaps the largest single cause of system failures in socio-technical systems. These are the dependability properties. I think this diagram should be visible to you. I'm just minimizing it. I should minimize the image that I have made here. So, principal properties of dependabilities are availability, the most important properties of a system dependability. Next one is reliability, safety, security, resilience. So, availability says that the ability of the system to deliver services when requested. The ability of the system to deliver services as specified. Safety, the ability of the system to operate without catastrophic failure. Security, the ability of the system is to protect itself against deliberate or accidental. Resilience, the ability of the system to resist and recover from damaging events or damaging from the cyber attacks. This is the description of the dependability properties of software. Other properties are there. You can consider it like repairability, maintainability, serviceability, error tolerance. Now, the topic is how to achieve dependability. See, dependability is one of the most important emergent properties of software system. So, how to achieve the dependability? I discussed with you emergent properties of software. I discussed with you dependability properties. I discussed with you what are the properties of dependabilities, and now it's time to discuss about how to achieve dependability. So, if you are in the phase of developing a software, then you can achieve dependability through these safety points. The first one is avoid the introduction of accidental errors when developing the system. Design V&V means verification and validation processes that are effective in discovering residual errors in the system. Then the design systems to be fault tolerant so that they can continue in operation when faults occur. Design protection mechanisms that guard against external attacks. Configure the system correctly for its operating environment. Include system capability to recognize and resist cyber attacks. Next and last one is include recovery mechanism to help restore normal system service after a failure. So these are the methods, these are the techniques through you can achieve the dependability of a software system. So, socio-technical systems. Software engineering is not an isolated activity, but is part of a broader systems engineering process. Software systems are therefore not isolated systems, but are essential component of broader systems that have a human, social, or organizational purpose. So, what are the equipment used in socio-technical systems? Hardware should be there. Hardware devices, some of which may be computers. Most devices will include an embedded system of some kind. Operating system provides a set of common facilities or for higher level in the system. Next one, communications and data management should there. See, middleware that provides access to remote systems and database should work or should come through the communications and data management. Next one is application systems, which specify functionalities to meet some organization requirements. Next one, business processes, a set of processes involving people and computer systems that support the activities of the business. Next, organizations, higher level strategic business activities that affect the operation of the system. Next is society, means rules and regulations, laws, agriculture that affect the operations of the system. There are interactions and dependencies between the layers in a system, and changes at one level ripple through the other level. For dependability, a system perspective is essential. So this is the diagram which shows how system engineering and software engineering collaborate for developing a particular socio-technical systems using software engineering concept. See, I discussed with equipment includes hardware, operating system, communication and data management, application systems, business process, organizations and society. So next we should talk about regulation and compliance. What are the regulations and compliances exist in a software system? Many critical systems are regulated systems, which means that their use must be approved by an external regulator before the systems go into service. Examples: nuclear systems, air traffic control systems, media devices. A safety and dependability case has to be approved by the regulator. It means in simple language you can say regulation and compliances says that before launching the software or before actual deployment of software at the end of customer, everyone should confirm the safety measures and security features, so that there should not be any type of problem exist or generate at the end of customer. Therefore, critical systems, a safety and dependability case has to be approved by the regulator, as I discussed earlier. Therefore, critical systems development has to create the evidence to convince a regulator that a system is dependable, safe and secure. Now the following rules applies to the socio-technical systems. System as a whole, and not simply the software element of that system. Safety related systems may have to be certified as safe by the regulator. To achieve certification, companies that are developing safety critical systems have to produce an extensive safety case that shows that rules and regulations have been followed. While developing a particular software, you should follow, it says while developing a particular software, you should follow the existing rules and regulation, existing protocol. I think I should drink some water. So, I was talking about regulations and compliances while developing a particular software. To achieve a certification, companies that are developing safety critical system have to produce an extensive safety case that shows that rules and regulations have been followed. It can be expensive develop the documentation of certification as it is to develop the system itself. See, the next one is redundancy and diversity. Redundancy means keep more than a single version of a critical component, so that if one fails, then a backup is available. See, redundancy and diversity is the most important factor for the software systems or in terms of digitization. Because suppose I am working online in a particular system, or I'm doing something or anything digitally on the network, and suppose if one security pillar falls, then there should be another one to handle all the working, to handle all the risks, and to back up my data so that I can use that in further working procedure. That is the redundancy says keep more than a single version of critical component, so that if one fails, then a backup is available, or a backup should be there. Next one is diversity. Provide the same functionality in different ways in different components, so that they will not fail in the same way. Redundant and diverse component should be independent, so that they will not suffer from common mode failures. Process activities such as validation should not depend on a single approach, such as testing to validate the system. Redundant and diverse process activities are important, especially for verification and validation. Multiple different process activities that complement each other and allow for cross-checking help to avoid process errors, which may lead to errors in the software. See, here is the term process activities such as validation. Validation is a part of testing. See, validation is a part of testing. It is saying here validation should not depend on a single approach such as testing to validate a system. It should not depend on a particular, or it should not relate a single submodule or task. It should be versatile for handling the security measures from all angles of the software. Multiple different process activities that complement each other and allow for cross-checking help to avoid process errors, which may lead to errors in the software. Dependable processes. To ensure a minimal number of software faults, it's important to have a well-defined repeatable software process. A well-defined repeatable process is one that doesn't depend entirely on individual skills, rather can be enacted by different people. Regulators use information about the process to check if good software engineering practice has been used. For fault detection, it is clear that the process activities should include significant effort devoted to verification and validation. There is a topic in software engineering, that is V&V model. Basically, it's a verification and validation model for software testing. It provides, the concept of V&V provides the more significant, more diversified properties of testing to the development software. Next is explicitly defined. A process that has defined process model that is used to derive the software production process. Data must be collected during the process that proves that the development team has followed the process as defined in the process model. Next, repeatable. A process that doesn't rely on individual interpretation and judgment. The process can be repeated across projects and with different team members, irrespective of who is involved in the development. Dependable process activities are requirements review, requirements management, formal specification, system modeling, design and program inspections, static analysis, test planning and management. These are the properties of dependable process activities while you are using the concept of emergent properties. So first one is requirement review. Requirement review basically is to check that the requirements are as far as possible complete and consistent, because requirement is the main and most important thing of the software. Whatever the requirement or whatever the type of requirement you get, you will develop accordingly. a particular product. So requirements plays an important role. Next one is requirements management, which focuses to ensure that changes to the requirements are controlled and that the impact of proposed requirements changes is understood. Formal specification. Formal specification where a mathematical model of the software is created and analyzed. System modeling. System modeling focuses software design, which is explicitly documented as a set of graphical models and the links between the requirements, and these models are documented. Next, design and program inspections. These are used in the development software where the different descriptions of the system are inspected and checked by different people. Next, static analysis. Static analysis where automated checks are carried out on the source code of the program. Next, test planning and management where a comprehensive set of system tests is designed. So now, dependable software often requires certification or both. So both process and product documentation has to be produced. Upfront requirements analysis is also essential to discover requirements and requirements conflict that may compromise the safety and security of the system. These conflict with the general approach in agile development. The concept of agile I already discussed while I delivering the video lecture on topic business area analysis. So these conflicts over the general approach in agile development of co-development of the software requirements and the system, and which minimizing the documentation. An agile process may be defined that incorporates techniques such as iterative development, test first development, and user involvement in the development team, so long as the team follows that process and documents their actions. Agile methods can be used, however additional documentation and planning is essential. So pure agile is impractical for dependable system engineering. So these are the topic that this is the topic of advanced software engineering of the module 1. I discussed with you people. That is the emergent properties of software system. What are the emergent properties? How does the hardware failure occurs, software failure occurs, operational failure occurs, and what are the dependability properties of a software like availability, reliability, safety, security, resilience. These are the important properties, and how to achieve dependability. In this I mentioned 6 to 7 points for achieving the dependability. After that I discussed socio-technical systems like equipment, operating system, communication and data management channels, application systems, business processes, organizations, society, and here I show how system engineering and software engineering incorporates for developing a socio-technical systems for the society. And these are the properties of emergent softwares like volume, reliability, security, repairability, usability, and the functional and non-functional properties of emergent softwares. And what are the rules and regulations we should follow for developing, for maintaining emergent properties while developing a software product. These are, and why should we focus on redundancy and diversity while developing a particular product, dependable processes, dependable processes activities like requirements review, requirement management, formal specification which deal basically with mathematics or mathematical expressions, system modeling which deals with system design and programming inspections means to translate a particular requirement into design with the help of any designing tool or language, static analysis, then test planning and management. And in last, I would like to say that suppose there are two organizations and both are functioning in software development. So if a particular software suppose there is one software company who I'm trying to say in simple terms, suppose there are two software organizations working for the software development product. So how can how user can be sure that this software company builds a particular good product in each and every aspect? So if I talk about two software companies developing a particular product, so customer will go and buy the product in a company where all the phases of emergent properties, all the phases of agile development, all the phases of software development activities like static analysis, design, test planning, system modeling, formal specification, requirement management, requirement review are there, and they will follow the organization will follow the security measures. And the main thing is the working procedure of software should be feasible, should be understandable by the customers. So this is the topic for today's lecture. I covered in video form with the help of Word document I prepared. If you have any problem, please discuss me. I will go through your problem and you will be satisfied and happy. Thanks to all of you.